All right, hey guys, we are getting ready to start our last unit in the first semester. You are almost halfway done with your 8th grade year. That's awesome. We are getting ready to start Unit 4, talking about functions. And this is the first lesson of Unit 4, talking about representing relationships. Okay, so let's talk about this. This is saying that this is a little blurb about how fast the space shuttle has to travel in order to thrust into space. And the answer, or how fast it has to go, is 5 miles per second. So that for every 1 second, it has to go 5 miles per hour, which if you think about that, that's pretty quick because a second's not much time at all, and it's going 5 miles in that 1 second. So if I wanted to write an algebraic expression for the distance in miles for any number of seconds, well, for 1 second, it goes 5 miles. For 2 seconds, 2 times 5 is 10. For 3 seconds, 3 times 5 is 15. For 4 seconds, 4 times 5 is 20. What am I taking each of these seconds times to get how far it travels? Well, if you said 5, you're right, because this was 5 times 1. This is 5 times 2, 5 times 3, 5 times 4, 5 times 5. So it's 5 times however much time it takes. So it's 5 times however many seconds I'm talking about, because seconds is t, because it told us up here in the expression that seconds is t, and I have to take 5 times that in order to get how far it has traveled. So now let's say it says describe the relationship in words. Well, we just said that in words. For every second, is times 5 in how far it travels. Okay? So this is to find distance. So for every second is times 5 to find distance, how far it went. Now it says graph the ordered pairs. Well, hopefully you remember that whatever's in the first box is going to be your x. So my x-axis is going to be time. So I'm going to go ahead and label that time. And it's the variable t, and that's in seconds. Okay, so then that leaves my other box, the distance, as my y. So I'm going to go ahead and label that. So this side box is going to be distance by the variable d, and it's in miles. So here's my two axes, and now I can graph them. Well, at 1 second, it went 5 miles. So my first one is at 1 second, it went 5 miles. At 2 seconds, down here at 2, it went 10 miles. So from 2, I go up to 10 and put a dot. 3, 15, 4 times 5 is 20, and 5 times 5 is 25. So there's my graph of that information. It says describe the shape of the graph. Well, if I look at this, if I were to draw my lines here, my graph would be a straight line. So that's how I would describe it. And it's actually a straight line going up or increasing. It's an uphill, so it's going up. Okay? Now let's flip over and talk about what that means. Well, up here it tells you that a linear equation, anything that's linear, forms a straight line. So if you have a straight line graph, it is a linear equation. Linear means straight line. Okay? Let's go down here and look at number 2, because I think we get the part of graphing. This is talking about, here's our equation, and it says that L is 0.95, because I got that from here, because each change here was 0.95. So to find L, I take whatever my quarts are times 0.95. 1 times 0.95 is 0.95. 2 times 0.95 is 1.9. So I'm going to take whatever my quarts are, however many quarts I have, times 0.95. So that's my equation. So now looking down here, using that equation, it says about how many liters are in 8 quarts. Well, I'm trying to find the L. If this is my equation, I am trying to find the L, and they give me a Q because quarts is Q. That's representative of my Q in my equation. So I can then put Q as 8 and divide it. Take 0.95 times 8, and that tells me how many liters I have, and the answer is 7.6. Okay, let's look at this next one down here. It says the total cost of tickets to the school play is shown in the table. So here's our table. So we have to write an equation. Well, first of all, we have to figure out how much each ticket costs. Well, for one ticket, it was $4.50. For 2 tickets, it's $9. For 3 tickets, it's $13.50. And for 4 tickets, it's $18. So let's find our change. Well, my change over here is 1. And we know that for 1 ticket, it's $4.50. So the cost is going to be $4.50 times however many tickets I want to buy. So I can tell you, I can write this equation because it's $4.50 per ticket. And now let's say I want to buy 500 tickets. Well, now I can figure out how much it's going to cost to buy 500 tickets without having to draw out this table to 500. It doesn't ask us to find 500, but it does ask us to find 15. So I want to see how much does it cost for 15 tickets. Well, I know it's $4.50 per ticket. So I take $4.50 times 15, and that gets $67.50. So if I wanted to buy 15 tickets, let's say a class wanted to go, a drama class, or let's say a group of Cub Scouts or a group of people wanted to go. Maybe there's just 15 people in your family, and they wanted to go see the play, and so they bought 15 tickets. In order to buy 15 tickets, each ticket costs $4.50. So for 15 people to go, it would be $67.50 total. Okay? Now let's look up here at number 3. Here's a graph. First of all, decide whether or not it's a linear graph. Well, does it draw a straight line? If I were to connect all of these dots, would it be a straight line? And the answer is yes. Yes, it would be. So we know it's a linear equation. And it says write an equation to find the number of miles ran after how many days. So we're trying to find y. And what do I do between each of my y's? Well, here, if I were to make a table out of this, because we're used to seeing this as a table, my x values are 1, 2, 3, 4, and 5, because they're the first number in my coordinate. And my y values then are my second number. So for 1, it's 3.5. For 2, it's 7. For 3, it's 10.5. For 4, it's 14. And for 5, it's 17.5. Well, I know that for one day, this is how many miles were ran. So if I run that many miles per day, it would be 3.5 per day. So let's say I want to say how many miles did I run in 30 days, a month. Let's say I want to calculate it for a month, so then I would take y equals, because y is the number of miles ran. If you run 3.5 miles a day for 30 days, for that entire month, then you have ran a total of 105 miles in that entire month. Okay? Let's look down here at number 4. Actually, I don't want to do number 4. I'm going to go on to the next one. Here it says the number of trees saved by recycling paper. Well, first of all, whoa, I don't know if that's going to be a straight line, because some of these are on this side and some of these are on this side. Well, let's draw it to see. If I connected all of these dots, does it make a straight line? The answer is yes. So is my equation linear? The answer is yes. So now we want to write an equation. And remember, anytime it says to write an equation, you should automatically remember that it's talking about y equals mx plus b. That's the equation that they're wanting to see. Okay? So in order to do that, I have to find my m and I have to find my b. To find m, hopefully you remember I can take any 2 points and subtract them, or I can just go up and over. In this case, it's probably going to be easier just to find 2 points and subtract them because some of these points are on weird parts of the graph. So I'm going to take this point and this point, and I'm going to subtract them. So my first one, my first coordinate is a 1, 17. My second coordinate is a 2, 34. Okay? So all I've done is I've written down my 2 coordinates, 1, 17 from this, and 2, 34 from right here. And now to find my slope, I'm going to subtract them. Remember, it's y2 minus y1 over x2 minus x1. So I have y2, and remember, it doesn't matter which one you make, y2 and y1. So I'm going to take 34 minus 17, y2 minus y1, over 2 minus 1. 2 minus 1 is 1. 34 minus 17 is 17. So my slope is 17 over 1. Now I have to find my y-intercept, where it's going to cross the y-axis. And if I look back over here, it tells me that I can put in my slope, whatever slope I find, and I can put in an x, one of my points for x, to find my y-intercept. So let's do that. Let's say that I put in, I gotta get some room over here. Let's use that same 117, the very first coordinate on my graph. And I know that my y is now 17. I know that my m is 17 over 1, or 17. Oops. I know my x is 1, so now I have to solve for my b. Okay? So if I look at that, 17 over 1 times 1 is 17. So I have 17 equals 17 times 1 is 17. So my b is 0. So now I know my m. I solved for it up here. And I know my b because I just solved for it. So now I can rewrite this equation as y equals m x plus b. Okay, another way to write that is I don't have to make this into a fraction. I can just leave it 17x, and I don't have to include the 0. So another way, a cleaner way to write that would be y equals 17x. Okay, now it says use the equation to find out how many trees could be saved if 500 tons of paper were recycled. Well, x is the amount of paper recycled, and y is the number of trees saved. So this tells me the amount of paper recycled, which is my x. So I can now put 500 in for x. And if 500 tons of trees were recycled, I would take 17 times 500. Did I say 500 tons of trees? I meant 500 tons of paper were recycled, which would mean that 8,500 trees would be saved. That's quite a few. Okay? All right. Let's look over here. Let's talk about this real quick, the representations of linear equations. Well, first of all, we have in words 12 miles per second, 15 miles per gallon, 17 trees per ton. Those are all things in words that mean a linear equation, okay? And just so you know, this word per right here means to multiply. So anytime you see per, this says 12 miles per second. That would mean 12 miles per second, which would be 12 miles times however many seconds you're talking about. Okay? Another way to write that is just like what we talked about. D equals 12 times S. The 12 miles times seconds, 12S. You can do it as a table, or you can do it as a graph. All of those are representations of linear equations. Remember, if you do a graph, it has to be a straight line. Okay. Over here, it says we're making a table. Let's go ahead and jump down here to this one. It says Paul earned $25 for grooming a dog. So we know that he earns $25 for grooming a dog. And that same dog he is going to board for $18.50 per day. Okay? So this is how he's going to groom this dog, and he is going to board this dog. So this is how much it is to board this dog. Oops, sorry, I can't see that. This is how much it is to board this dog, and this is how much it is to groom this dog. And we want to know, okay, so if it's this much to board him, and if it's this much to groom him, we're going to then make a table. Okay, so let's talk about this. We know that he's going to pay this much no matter what. What we don't know is how many days he can groom it. So y equals, this is $18.50 per day, so this is going to be $18.50 per day plus the $25 to groom the dog. Okay? So D is going to be the number of days, and C is going to be the cost. So that's what we have to look at. Okay? The total cost. So my X values are my D, is the number of days. So my X's are my number of days. And it wants 5, 6, 7, and 8 days. And here's my equation. Y equals 1850X plus 25. And so I have to plug 5 into this equation. So take 1850 times 5 plus 25. It's $117.50. Now put 6 in there. I'm just replacing this X with this number. So in this first one I have 1850 times 5 plus 25. In the second one I have 1850 times 6 plus 25. 1850 times 7 plus 25. And 1850 times 8 plus 25. Okay? So if I did that, 1850, I've already done 5, so let's do 6. 1850 times 6 plus 25 times 6 plus 25 is $136. 1850 times 7 plus 25 is $154.50. 1850 times 8 plus 25 is $173. So this is how much it would cost to do each of these times. And now I can graph that. Well, for 5 days, it was at 117.5, so that's going to be about right here. That's kind of hard to graph accurately because our graph is not broken down into that small of increments. For 6 days, it's at 136, so here's 130. It's going to be about right here. For 7 days, it's 154.50. So here's 150. It's going to be about right here. And for 8 days, it's going to be 173. About right here. Okay? So roughly, this is what our graph will look like. Okay? All right, guys, I think that covers all the information that we need for this chapter. Go ahead and write down your questions in the margins if you should have any. Bring those back to class tomorrow. This is kind of a culmination of everything that we've been doing for quite a while now, since about before Halloween, talking about slope and how to graph lines and how to write equations. And so hopefully you're pretty comfortable with this. If you have any questions, let us know. Have a great night. Bye.